Hello everyone, and welcome to today's presentation. I'm excited to have you here as we explore the compressor overview and symptoms. Today, we'll be focusing on the model DSH-3500 AVXBM84, which operates at 380 volts, 3 phases, and 60 Hz, spinning at 1750 RPM, and uses R22 or R47C refrigerants. We'll discuss where it's typically used, in medium temperature chillers and package units, and what common symptoms you might encounter. We'll cover signs like loud metallic sounds, trips within seconds, and low current readings, which indicate underloaded or abnormal operation. So let's get started and dive into the details. Let's take a closer look at some common causes that can affect our system's performance. First up is low refrigerant, or what we call starved suction. When the suction pressure drops below 60 psi on R22 systems, you might notice a dry sound and bubbles in the sight glass. This indicates there's not enough refrigerant circulating properly. The solution here is to add refrigerant gradually until the pressure stabilizes, ensuring the system runs smoothly again. The second cause is reverse rotation, which happens when the phase sequence of the power supply is incorrect. This results in a harsh metallic sound and no rise in discharge pressure, which signals a serious issue. To fix this, you simply swap any two of the power leads and retest. Correct phase sequence is crucial for the compressor to operate properly. These issues highlight the importance of proper charge and correct wiring, both of which are essential to maintaining system efficiency and preventing damage. Addressing these causes promptly keeps our systems running reliably and helps us avoid more costly repairs down the line. Let's talk about cause 3 and 4, which are closed valves and oil foaming. When we have closed valves or a line blockage, it causes a restriction in the system. This restriction means no gas can flow properly, which results in low amps and a quick trip of the compressor. To fix this, it's important to fully open both the suction and discharge valves and to ensure the filter dryer is clean. Now, moving on to oil foaming and crankcase heater issues. When the crankcase heater is off, refrigerant can mix with the oil, creating foam. You'll notice this as a foamy sight glass and some vibration. The key here is to keep the heater on for about 8 to 10 hours before starting the system. This helps prevent oil from foam and ensures proper lubrication and system operation. By addressing these causes, we can improve system reliability and prevent unnecessary shutdowns. Now, let's move on to causes 5 and 6 that we often encounter in equipment issues. First, oil contamination and metal debris. If you notice dark oil, that's a strong sign of bearing or valve damage. It's crucial to drain and replace the oil, ideally using the 3GS method, which involves cleaning the filter and pulling a deep vacuum to ensure all contaminants are removed. Keeping the oil clean helps prevent further damage and keeps the equipment running smoothly. Next, electrical faults, specifically single phasing. When one phase is lost, it causes unbalanced amperage, which often leads to tripping. The key here is to check the current balance across the phases, aiming to keep it within plus or minus 5%. This helps us identify issues early and prevent unexpected shutdowns. Both of these causes tie into our overall theme of proactive maintenance and early detection. Addressing oil contamination and electrical faults promptly can save us from costly repairs and downtime later on. Let's take a look at what healthy compressor behavior looks like during startup. First, you'll want to listen for a smooth humming sound, no knocks or unusual noises, which can indicate problems. Next, check the suction pressure. It should be in the range of 60 to 70 psi, and the amperage should be between 55 and 60 amps, ensuring the system is balanced and operating efficiently. You'll also notice a steady rise in discharge pressure as the compressor runs, which is a good sign that everything is functioning normally. Additionally, the oil should be clear and free of foam. If you see foam, that's a warning sign. In that case, you should stop the unit, replace the oil, and keep the heater on overnight before restarting to allow the oil to settle and prevent issues down the line. These indicators are crucial for confirming the compressor is starting up correctly and running smoothly. Remember, maintaining these healthy startup signs helps ensure the longevity and efficiency of the entire system. Let's walk through some essential preventive tips before starting up your equipment. First, it's crucial to check the refrigerant charge and ensure proper rotation. This helps maintain efficiency and prevents potential damage. Next, open the valves and confirm that the flow is unobstructed, ensuring your system operates smoothly. Preheating the oil for about 8 to 10 hours is also vital. This step helps avoid thermal shocks and prolongs component life. After preheating, inspect the oil's color and clarity. Clear, clean oil indicates good condition, and any discoloration might signal issues. Then, verify the electrical phase balance. Proper phase balance ensures your motor runs efficiently without unnecessary stress. And if you find the oil is clear but the problem persists, it might be internal faults, and in such cases, sending the equipment to the rewinding workshop is the right move. Overall, these steps form a quick but comprehensive checklist to help prevent issues before startup and keep your system running reliably. All right, as we wrap up, I want to leave you with this final reminder. If you notice that the oil is contaminated, the best course of action is to replace the oil completely and then wait at least 10 hours before attempting to start the compressor again. This waiting period allows any residual contaminants to settle and ensures the system is clean. On the other hand, if the oil appears clear but the problem persists, it's important to stop the compressor immediately and return it to the rewinding workshop for a thorough mechanical inspection. This step is crucial because persistent issues, despite clean oil, often point to mechanical faults that need expert attention. Remember, these steps are essential to maintain the health of the compressor and prevent more serious damage down the line. Staying vigilant and following these procedures helps us ensure reliable operation and prolong the lifespan of our equipment.